So we had that really simple diagram where we talked about a water pipe. Excuse me, I'm looking for my marker. What did I do with that? Those are a nice one. So I'm not using one. Nope. All right. So we went through that really simple diagram, and we said, all right, the voltage is a water pump. The pipe is the resistance. Now, there's a couple of things that affect how much water can go through that pipe. The diameter of the pipe, the material of the pipe, is there a filter in there? Is it a clear pipe? Is there gravel in there? All these things affect how much water will travel through that pipe. Now, what I need to do is I need to come up with an equation that describes that. And that's this. Resistance. What we know as resistance from our vocabulary, which means the amount of a resistance to the flow of charge. It impedes the amount of charge to travel through a circuit. Is equal to rho. Oops, not a rho. Excuse me. Rho. There we go. Rho. Now, rho is one of those things that refers to a density. You'll see it over and over again if you ever go on and do some things in physics. You'll see the term rho over and over again. In this case, rho is referring to a property of a material. Copper has its own rho value. Gold has its own rho value. Most of your hardwoods have their own rho values. Water has its own rho value. It's just a material property. It's how easily does charge move through this material. Okay? So in some cases that rho value, in the case of copper, it's 1. And in other cases it may be thousands. Okay? Cool? And then that rho value times the cross-sectional area of that pipe. Okay? Divided by the length of that pipe. Cool? That is the definition of resistance. Now, when we look at a pipe, we're looking at, this is the cross-sectional area, and this is the length. Okay, so that's the length. This is the cross-sectional area. It's this area of this circle right here. Okay, so that is what makes up the resistance. So if you were given the rho value of a piece of material, and you could measure the area and the length, you could determine what its resistance is. How much would it actually impede the flow of charge? Would it only allow 2 coulombs through? Would it allow 20 coulombs through? Remember, we got to have a voltage there too. But anyway, that is a basic property of resistance. Now, remember, rho is a property value. It's the material itself. That material, what it's composed of, has a huge effect on how much charge allows through. That's why we build wiring out of copper. The cross-sectional area, oops.